Hello, welcome to Chapter 4. This is Professor Clemens. Let's talk about correlation and prediction. Objectives. Calculate statistics to understand the relationship between variables. Calculate and interpret the Pearson product, moment, correlation, coefficient, and the standard error estimate. Use scatterplots to interpret the relationship between variables and differentiate between simple and multiple correlations. Correlation coefficient. An index of the linear relationship between two variables measured by the Pearson product moment correlation coefficients. R ranges from -1 to +1. R of 0 indicates no relationship. And again, remember when we refer to R, that is the correlation coefficient. Here's positive. Here's a scatter plot of correlations between pull-ups and chin-ups. Note the scatter plot equals a graphic representation of the correlation. So you have chin-ups, the number completed, and the correlation between the pull-ups, number completed. This is a scatter plot of correlation between the body weight and pull-ups. So you can see how the correlation between how much body weight someone has compared to the number of pull-ups that they can do. And here's a scatter plot of 0 correlation. The closer the data points come when plotted to make a straight line, the higher the correlation between the two variables, or the stronger the relationship. Let's calculate R. Arrange data in paired columns, X and Y. Square each value and each Y value and place the results in 2 additional columns. Multiply each X by its corresponding Y and place the results in a new column called cross product or XY. Here's that calculation. Determining the sum for each column. You use the following formula to calculate. Now keep in mind we have calculators to do this and we have software programs that will calculate this for you. The coefficient of determination represents the proportion of shared variance between two measures. The variation not accounted for by distance and the variation accounted for by distance. So you can see those two coefficients of determination there. The limitations of R. If the relationship between the variables is curvilinear, the ppm correlation coefficient will underestimate the true relationship between X and Y. So your ppm will only indicate the linear relationship. The correlation does not necessarily indicate cause and effect. Some third variable may be the cause of the relationship detected by a high R value. And then also greatly influenced by the variance of range of the variables measured. So there can be a wide range there. Here is a graph of a curvilinear relationship. So you can see performance and arousal, arbitrary units, both on the side. You can see how those are correlated right there. And here's a correlation example of range restriction. Whenever a sample has a restricted range of scores, the correlation will be reduced. To take the most extreme example, consider what the correlation between high school GPA and a college GPA would be in a sample where every student had the same high school GPA. So the correlation would necessarily be 0. Estimating one variable, y, from one x simple correlation or more than one x multiple correlation variable. You can also do prediction. If X and Y are highly related, then X can predict Y to some degree and vice versa. But this still does not imply cause and effect relationship. Here's a plot of a straight line. Linear prediction or regression, statistical method used to predict the criterion, outcome, or dependent variable Y from a single predictor or independent variable X. Prediction equation shares the same form as the equation for a straight line in plane geometry. Here's calculating regression. We can use the following equations to calculate B and C. There are also errors in prediction. Unless the correlation coefficient is -1 or +1, Y will not necessarily equal Y. So there's an error that represents inaccuracy of our prediction of y based on the prediction equation. Here is an error residual scores, pull-ups compared to weight, and then you can see the calculation right here. And again, you have SPSS programs, statistic program packages, and different things that can help you calculate these. You just need to know how to plug in the numbers, which hopefully you'll learn a little bit about that in the assignment this week. Standard error of estimate, CEE, statistics that reflects the average amount of error in the process of predicting y from z. This is also called a standard error, SE, or standard error of prediction, SEP. Multiple regression. This is a more complex prediction of y and can be developed with the use of more than one predictor. The discussion. Refer to figure 4.5. This is in your book. This figure illustrates the relationship between your VO2 max and distance run. Consider what happens to the variation explained and the resultant error variation if additional variables such as gender and age are added to the regression equation. In summary, correlation and prediction statistics lay the foundation and provide many of the necessary skills for measurement and evaluation. These skills are necessary for generating measurement theory, as well as for applying reliability and validity concepts to practical problems in exercise and human performance.